Dr. Gold in the lab, Twitch stream glowing, formulas flashing, minds wide, knowledge flowing, equations on the board, numbers never sleep, teaching math and physics while them haters count sheep. Actual education, tune in and get schooled, flipping textbooks, breaking all the rules, from Newton to Einstein, concepts elevate. Keep the stream, it's the key to our fate. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice. Got the Pythagorean triangles about to flex, quantum theories on deck, breaking all the specs. Relativity theories, worlds getting small, grasp the universal laws, standing tall. From the atom to the cosmos, we rolling deep, grazing up the stars, no time to sleep. Black holes and supernovas, concepts we unfold, brain power heavy, yeah, that's Dr. Gold. Dr. Gold dropping gems, knowledge raining down, actual education making scholars all around. Perpendicular minds, angles sharp as ice, maths and physics, yeah, the future's real nice.
What's up, everybody? One second, I'm gonna project this. Yeah, there we go. Nice. Oh, I'm quite tired today. I got like no sleep last night. I was tutoring a kid until, what was it? 1:30 a.m. in the statistics, and then I had to wake up at 6 a.m. to drive my sister to the subway so she could go to a medical conference. She's a pediatrician visiting for the week. And then, I had to go to UCLA today to do some paperwork and then get some advice about teaching this next quarter from someone who's taught it actually for like 7 years already. And someone who actually really cares about teaching for this type of class. So, what's up, Sensation? Good to see you, dude. Yeah.
So,
Wagwan.
Can we say that? I-S-U-B-D.
I subbed. Oh, you subbed? Oh, thank you, Eduardo, dude. Appreciate that, man, dude.
S-U-B-B-E-D. Fucking sort your head out.
It's okay. Let them say what they want to say.
I'm joking, of course.
I know. We appreciate that. We appreciate the... I think, dude, for a second there, YouTube was showing me 12 live viewers. I was like, wow, that's impressive. From the start. And then we're all bots. YouTube Shorts actually does pretty well for, I will say, for engagement. I think Google's probably really trying to like pump the algorithm to get more stuff and views and get more people to use YouTube Shorts because they're, threatened by TikTok constantly. Yeah, let's see what we did. Let's see how much we've done on the last one. Yeah. Oh yeah, the last one did 375 views. That's not bad. What's up, gaming? SMG Bros Gaming. What's up, dog? Big dog.
Submachine gun. SMG.
Yeah, we already got 2 likes on today's stream. That's crazy. Nice.
Oh,
welcome.
is TikTok back on?
No, I'll sort that out. I honestly, well, we're getting some engagement from TikTok. I thought it was cool. I think I have to run it through I have to run it through the second PC because they're saying I have to like reapply for access. I'm like, whatever. I'll figure it out next week. It's okay. SMG Pro says, hello, I have a question. I want you to read it out loud. Usually when someone says they have something they want me to read out loud on the internet. It's not
How many
appropriate.
times we can't shout the N-word?
We can't do it. Yeah, we can't do it. I'm sorry.
I mean, we can if we're in like a hip hop club, but you know.
Yeah,
Just,
no. I'm the wrong skin tone. But yeah, if you want to say something, that's cool. Miss Sasha detention and no more free lunch. What? YouTube's popping off right now. That's cool, man. Yeah, if you guys ever, if you're watching us on YouTube and you're new to the, what we do here, there's a way for you to submit homework questions for us to go over live on the stream here.
that didn't work.
Didn't work, did it? Well, hang on, let me do that. Or is it yeah, that is pretty rude. Was it? Oh, actualdiscord.com/submit. That's what it is.
It is on the screen for people in short.
I know, but people can really just only read the chat. They can only do so many things at once.
Actualdiscord.com/submit. Get your questions in.
Get your questions in. We'll go over them live on the stream. Yeah, people will figure it out. It's okay. This is gonna be a shorter stream today, anyways, because I gotta go run and teach another kid in an hour. But I almost thought about canceling today's stream because I was just so exhausted. But I said, no, we shall do it. I shall show up. But yeah. Anything else new? What do you think? It's Wednesday.
It is Wednesday, my dudes.
It is Wednesday. It's past the Ides of March, right? Yeah. Someone told me someone was messaging me like frantically being like, hey, did you know Caesar died? I'm like, and I wanted to respond and be like, oh, I'm so sorry. Like, I'm so sorry for your friend Caesar. I'm like, wait, Caesar who? And she's like, it's the Ides of March, you silly. Like, I don't think anybody gets that.
Even I didn't.
You know what this is though? The Ides of March. Ides of March.
I've heard of the Ides of March, but I didn't know it was anything to do with Caesar.
It's when Caesar got stabbed. The Ides of March is the day on the Roman calendar marked as Ides. Okay, but I thought it's when Caesar. Yeah, the death of Julius Caesar. Yeah. SMG Gaming Bros. Like, why? I don't know. Like, people. We have weird. I forget where this is mentioned. Oh, isn't it Beware the Ides of March? Where's that from?
Shakespeare.
Is that? Shakespeare. You are right. Yeah, nice. Okay. I wonder if the kids even read Shakespeare anymore in school. You tell us in the chat, guys. Do you guys still read Shakespeare? Does your teacher still make you read Shakespeare?
I very much doubt that even if this is, I'm gonna cast aspersions towards the American education system now, but
Yeah,
I mean,
it's alright. It's alright.
even if you were reading Shakespeare, it would be in modern English, wouldn't it? Realistically.
It's still it. I mean, it is in modern English, but it's still difficult to understand because it's. What do you mean by modern English? Like, is
we're speaking modern English right now. Shakespeare was originally written in post-Middle English.
Yeah,
early
it's
modern English. So
it's when I read it, it was weird. It was like, and thus the da 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 da. You know, like it's like that complicated English that I don't really understand. Yeah.
That's Omar.
I see. Yeah, they do that. Yeah. Well, at least I did that. I don't. Yeah, maybe the kids these days have like the ChatGPT translation of it.
Yeah.
Isn't a Glock switch considered an SMG?
Yeah.
Good question. Is it? No. You mean a Glock with an automatic trigger? Is it SMG? Yeah. Sensation is our expert on firearms. He says yes.
It is. So,
I don't know.
and they're very hard to fire, actually.
Oh, I bet. Yeah. Because it's not really made for that. You don't really have like a front stock or anything, right? You're just like holding.
Yeah.
There's
There's no way. You just have to have like extreme strength to fire the thing straight, or else the thing just flies out your hand.
Yeah. Kind of defeats the purpose of it, you know.
Yeah.
It's not gonna be accurate.
Buy a rifle if you're gonna do that.
Yeah, if you really need high rates of fire, go get a rifle. They had this argument with like bump stocks, right? Have you heard the argument of bump stocks, Sensation? Yeah, right. Yeah, they were saying like, oh well, they're constitutionally legal. It's a loop. It's a workaround from like getting a fully automatic rifle is to have a bump stock, but in reality, it's a terrible thing to have practically because you're using the recoil of the gun to hit the trigger again, which makes it incredibly inaccurate. So people making the argument of, oh, I need my bump stock to defend myself against a bear. It's like no dog. It's just gonna decrease your chance of hitting the bear. Yeah. Anyways, I forget how we got on the tangent. Oh well, it was in the chat. Okay, that's cool. Adarsh does have a question, which is cool. Let's see anything else in the chat here. No. What's up, P127? Do you have any ever have like physics question stuff you want to go over? We'll do them, man. Gold studied at the University of Yapology. I'm a yapper. I do like to yap. I do enjoy the sound of my own voice. I think that's one of the great things I invented, or not invented, sorry, that I upgraded in my studio here, is I now have a feedback system where I can hear my mic through my headphones.
Oh.
Do you have that
couldn't
sensation? Yeah. Well, it's useful, especially when I have, if I have like the second guest over here.
Yeah.
It enables me to hear like what they're saying at the same time that I'm talking as well. I could not listen to my own voice. It is weird at first, but I kind of enjoy it. It helps me monitor whether my levels are too high or not. Because then you can hear the distortion.
I can't hear over my own voice, if that makes any sense. Right, hang on. If I do this now, I should be able to hear myself. Yeah.
I can hear you.
I personally am louder than the feedback is.
Oh, interesting. Okay. Well, it also depends if you're wearing like open back headphones. So mine are closed back. Do you have open back or closed backs?
I've no idea.
Oh, yeah. Mine are closed back, which well, it means like can you hear outside as easily?
Well, yeah, but I would be able to anyway.
Yeah. It's like, I can't hear anything anyway. No. The thing I'm talking about is here we go. Open versus closed back. Closed back are generally better for sound isolation. Open back, the sound reproduction is better, but if you're in a noisy room, it makes things bad. And also other people can hear what you're listening to. Which, yeah, so here's like the difference between like a closed back and open back headset. What's up, the boss?
They're definitely closed.
Yeah, yours are probably closed. Most headphones are closed. Open ones are like really like audiophile, high-end headphones. And honestly, they're annoying for other people around you. So that's why most people don't have them, unless you're on the subway just being a nonce.
As opposed to the pranks that just sort of have their phones and it's like, where's your headphones, mate? We can all hear your conversation. Shut the fuck up.
Yeah, I know. Yeah. Okay, cool. Here, I think Adarsh, you in the chat. We'll do your question, and then we'll get started. We have some other ones from was it Swab we can work on that while we wait for people. Okay, cool. All right, let's start off the stream. Welcome to Office Hours. My name is Dr. Zach Education. Just to help you with math and science homework. All sorts of fun math and science. Today, the first question is from Adarsh, and it is what looks like an inequality with an exponential. Oh, that's gonna kind of mess with us, right?
Well,
yeah. Don't we have to just like test
no,
these?
it's not. It's not messy. It's not messy.
We should do some. We should do some messy inequality stuff after this. There are some messy ones. You know what I'm talking about?
Yeah.
Yeah, they can get weird, especially with like absolute value and inequalities. That's a mess. Okay. Well, let's
I have a
see.
few things we can talk about if we need to, but
Yes.
it's interesting.
Specifically
but-
with this question, or like.
Well, not with this question specifically, but with other things too.
Okay, that's cool. With this question, this is the variable we're looking for. We're
So
trying to
here's
get
what
this.
I would do here. Here's what
I
I
divide
care
by
about.
27, right?
So
What would you do?
I have the way I see. So first of all, let's divide by 27. 'cause that's
I agree with
annoying.
Yeah, this thing right here, I don't like this. This is messing up my system. So we're gonna divide by 27. Which divided by
And
27
that's actually nice.
is the same thing
Huh?
as multiplying as 1 over 27. So now we have
that's
2
okay.
over 3 to the x is less than or equal to 16 over 3 times 27.
Mhm.
Which we know what 27 is
No,
also another thing in
Okay,
terms of threes,
wait right
right?
there. Wait right there. Don't do anything
Okay,
else
wait right here.
yet.
I'm gonna wait.
Now
Wait.
we have something I want to do. Let's break 27 into its friends, into its factors.
I agree. Yeah, 27 is nice because 27 is the same thing as 3 to the third, or second. Sorry, no, third. I had it right the first time.
And that times 3 is 3 to the 4th.
Exactly. So this 27 is the same thing as 3 to the third.
No, and then 3 times 3 to the 3rd is 3 to the 4th.
3 to the fourth, right? Because this
We
is the
don't
same
wanna
thing
not-
as 3 to the first times 3 to the third, which is 3 to the 1 plus 3. That's gonna be 3 to the fourth.
And then
Nice.
what is 16 also?
Ooh, I like that. Yeah, because 16 is also... Yeah, the reason why Seth's doing this, why Seth is breaking everything into smaller numbers with exponents, is it'll eventually make this easier to see. Oh, I thought I said 10.27 to the 2/3. Oh, yeah, that would suck, Hannah. Yeah, no. This is question number 10. This was 10.27.
You gotta get in the hospital now.
That'd be some pain. I don't want to do that. Okay, but yeah, Seth is right. Let's write 16 as 4 squared. I like that. Which, well, let's think about this, Seth, right? What's another way to write 4? I know we can write 4 as 2 squared. So instead of saying 4 squared, I'm going to say this is the same thing as 2 squared, which is going to be 2 to the 2 times 2, which is 2 to the 4th. So this is really cool, actually, the way Seth is doing this. This is the way you can solve this question without even using logarithms.
And
It's just getting things to the same base, right?
And then now we have a 2/3 to the 4th.
Mm-hmm. So since both these numbers are being raised to the same power, we can like almost factor out the power and write this as 2/3 to the 4th.
We can see that backwards as well. That's
Yeah.
how you know you've done something.
Now this is super cool, right? Because 2/3 to the x less than or equal to 2/3 to the 4. This
I was
is the
hoping
same
for that because
number.
it would be annoying if it was not.
Yeah,
I was hoping it was in a.
it would be hard to do with a calculator for sure, right?
I was hoping it was in this to change the base. And
Potential pitfall ahead. Yeah. Something could mess up, Jeff. Right? This thing always messes with me. Okay, but I see x, and it's something with 4.
now,
If this
let
was
me-
just
let me
a
say-
straight equals, this would be nice. We would just say x
Now
equals.
now let me say this next thing.
Yeah.
A logarithmic, a exponential function is a what?
An exponential function is a what?
Is a what?
Is a 1-to-1
Is it
function.
always a what?
It's always a 1-to-1 function, right?
So is an
Always
increasing
positive.
function.
It's always
It's always an
positive.
increasing function.
It's always increasing. Well, is it?
See, is it?
It's always increasing as long as this is greater than 1. Otherwise, it's not.
What type of function is this? Then
Oh, this is a decay function then, right?
this is it. So what must be true?
Interesting. Okay. So then this must be bigger than this. X must be greater than or equal to 4.
Area. Yep. That's
Yeah.
the direction it was.
Yeah, the reason why Seth says this is that
That always fits the square root.
yeah.
That's
So if-
it's just fair.
if for instance we have a function, that's a cool way to look at it intuitively. Hi guys, you're a maths graduate. I'm a physics PhD. That's kind of like I did a little bit of math, you know. But yeah, we can help you with math if you want. We're helping someone with
I
math
can
right
also help you with your English, for fuck's
Yes.
sake.
now. Sensation can help you speak.
British
Wha-
English.
Okay, why is if
Yeah,
if
the
this
real
is-
English, go fuck yourself, right?
the real English. Go fuck yourself. All right, if this is a fraction that I say fraction, technically like 4/3 is a fraction, but when I say fraction, I mean something that is, less than the absolute value of it's less than 1. That's kind of what I mean. So something that is in between -1. We're gonna say r -1 and 1, and this is being raised to the x power. That's gonna look like some. Oh, sorry, not even negative. We really don't want negative, do we, Seth? Here, actually, I want this. Yeah. If it's a positive, if it's negative, then it
Well-
starts doing wacky shit, right?
Now here's a better way to write. There's a better way to write that.
Yeah, that's a better way to write it.
There's a better way to write that. The absolute value of r is less than 1. Right. That's what we were. That's what we were paying
But
attention to.
I think I want R to be positive though, because
That's why I set up the value, because the negatives go away with the power.
oh okay,
The absolute value R less than 1.
yeah,
If it was negative, it is going to become positive.
correct, yeah, okay, yeah.
That's what I'm saying. That I'm saying
Yeah.
that also says that is
The absolute value would help you there, yeah. If this is between 0 and 1, this will decay, because what's happening is you're multiplying by a small, you're getting like the fraction of a fraction of a fraction. You're getting like the piece of a piece of a piece. So if you're doing like 1/2 and then like 1/2 to the third, that's like 1/2 of 1/2 of 1/2, which is just gonna get smaller and smaller. So yeah, this is an exponential decay. Is that what we call it, exponential to decay? Whereas, if you have a function where this thing here, r is greater than 1 to the x, then this is an exponential growth. What's up, Slayer? First time chat. What's up, Sir Slays? Yeah, so this is an exponential growth then. Okay. It's been a while, but I'm trying to get back into the mathematics education. Yeah, no, for sure, man. You know, ain't no time like the present. They say the best time to plant a tree was 50 years ago. The second best time is today. So
Good times.
yeah, good times. How did you find your physics degree course? What do you mean? How did I pursue a physics? Well, that's a very large question there. Of like, I applied to UCLA is what happened, and then I went and did physics research for 10 years. If you're asking like why I chose it, that's a bigger question. Why is this on my feed?
Because we're awesome.
Yeah, because YouTube wants you to learn math. The algorithm's super hot today.
Phone. You said something in front of your phone. You said something stupid, and the phone's gone. I know. We'll add up some good math education.
We're gonna learn you, dude. UCLA.
Okay.
Yeah.
I'm not going to add one.
Well, what's up?
Two little count.
What?
I'm gonna like to do just two more problems for this.
We have 2 more problems for this case.
For
You
this,
wanna try
no,
2 more
no. I'm
problems?
saying I'm gonna give 2 more problems for this type.
Okay.
That are both gonna be a little bit harder. One is gonna be a nicer one. One's gonna be a little bit mean. Let's start with the nicer one. Let's say instead in our start problem, it said this instead: 27 times 3/2 to the x.
You want 27 times 3/2 to the x.
Same problem otherwise. It's just that the
And then you want to do this.
fraction
You want to say this is greater,
Same
less than or equal
problem.
to 16/3.
same problem, but the fraction I flipped on you,
Okay, that's cool. We'll try it.
which we know that's gonna be annoying. Because now we have negative ats to deal with.
Yeah, divide by let's do some stuff here. We'll get to the same spot, and let me answer some of the viewer questions. Someone's saying, as in, did you enjoy it? I did enjoy physics. Yeah, I mean that's why I picked physics.
There's no screenshots yet, so we're good for now.
Yeah, we're good now. And what was my favorite topic? I liked E&M. I liked electricity stuff. So that's why eventually, when I got to my later years in college, in undergrad at University of Texas, I started getting interested in plasma physics. So plasma physics is really cool. And that's what became my interest when I applied to grad school, is to go find a plasma physics program. And I got accepted, so it worked out. And I graduated, and now we're here. So, I guess I'm the English teacher. Why is there a Brit speaking? Yeah, because that's Sensation, Sir Sensation. He's our across the pond expert, and general cool guy.
Expert at abuse.
Expert. The beatings will continue until morale
improves.
Yes. Did you cover medical physics? In my program specifically, no. That's more of like a biology hybrid class is what that is. Medical physics, I think, refers mainly to like radiology type stuff, like MRIs. It's about using, or what is it, like proton beam treatment stuff. They use some physics stuff to do medical stuff, which is cool. I didn't really cover it specifically because it's more of a specialty thing.
Just
you guys got
radiology. Sorry.
Yeah, what about radiology? No, go on.
Well, wasn't that a thing? quite a lot of the radiology machines in the US went wrong, and they actually ended up irradiating a lot of people.
Uh-oh. I mean, probably.
When was this? The 80s, I think. The 70s or the 80s.
You know, I think you get something like the equivalent of 1,000 X-rays when you fly in an airplane. I think that's true.
1,000 X-rays?
I think it's like 1,000 X-rays. Oh, so let's go
That can't be right. After 1,000 X-rays, surely you'd have radiation sickness.
How many X-rays worth of radiation do you get from flying a plane? Oh, A-level physics. Oh, okay, that's cool. Oh, here we go. Here's the document. Where is it? Okay, here we go. Okay. Okay, it's called like millisieves, I think. I thought it was Rontgens. I thought Rontgens was it. Or they call it the banana equivalent dose. Oh yeah, because aren't bananas radioactive?
Yeah, they're pretty much completely potassium, aren't they?
Yeah. Yeah, super cool. Okay, well look.
I knew a guy that had to have dialysis every week, and he used to eat a lot of bananas and drink a lot of Lucozade.
Oh, interesting. Lucozade, yeah. Radiation am I getting? I don't know, there's like websites on this stuff, but okay, there we go. So eating a banana is 0.1 microsieverts. A chest x-ray is 50. An airplane flight from New York to LA is 40. Okay, so sorry. So an airplane flight is 1 x-ray is what we would say. And that's actually a pretty long flight.
50,000.
The 50,000 is a radiation worker medical. That's the max allowed for a radiation worker per year. Yeah. Please, law, teach me. Yeah, we'll teach you, dude. We'll get you.
So back
yeah.
to where we were. No?
Yeah, let's go back to math. Sorry. Yeah. The radiation's cool, though. Okay. Let's see. Where was it? It was this. Okay. So we were here, Seth, right?
Yeah.
So now I want to rewrite this thing as something like this. Yeah.
No.
And what I know is I can flipsies, right? I know that 3/2 is the same thing as 2/3 to the -1. If you raise anything to the -1 power, you flip the fraction. Okay, cool. So this is 2/3 to the -1 to the x is less than or equal to 2/3 to the 4th. -1 to the x is just multiply each other, -x. So I get 2/3 to the -x is less than or equal to, wait, sorry, less than or equal to 2/3 to the 4th. So again, we have our dilemma with 4. Something with 4
No,
here.
I did it this way. The reason I did it this way is now we have a negative annoyance. That negative.
Yeah,
annoyance.
this is, yeah, now it's something with -4, right?
Well, is it?
Well, if this was a straight equal sign, right? Then I would say that -x is equal to 4, which would tell me that x is equal to -4. However, we have an inequality here. So it's a little tricky. So we know it has to be one of the equals. It's either less than or equal to or greater than or equal to. Right? It's either this one or this one.
Or it's a taste by taste method, which we hope it's not. Which you don't think.
Ah, yeah, it could be that. You're talking about on the number line where it's like this. We got to do this.
I was not a fan of absolute value when it did that.
Yeah, absolute value is
With
the one. That
a
does that.
polynomial on the side. I decided to.
Yeah. Okay,
But
so
it's not taste by taste either.
okay, let's think about this. I want this to be bigger than this, which means this has to have a higher power up here. So in order for it to have a higher power, it needs to be more negative than -4. All these double negatives mess with me. Yeah. Valerian says, just want to say that I appreciate what you guys are doing in terms of helping others on YouTube with something that matters. Keep it up, guys. I'm rooting for your success. Wow, thank you, dude. Look at that in the chat, dude. Valerian Shorts, I appreciate you, man, dude. That's sick. Anyways, yeah. So this is less than or equal to -4.
Jeff says
Thank-
it's easier if you flip them again. If you flip them. Which it
Oh,
is.
oh, I like that. Actually, yeah, that's actually a good idea. Yeah, okay.
Give
So
them
what you're
another
saying is
flip.
that instead of doing
'Cause
this,
you want them as 3/2.
I should have written this as 3/2 to the x is less than or equal to 3/2 to the -4.
Yeah, now it's an increasing function. We
Okay, now
switched
they're
the
increasing.
red-
So, oh, I see. So now, oh, wow,
Notice
this
that
is
changed the
messing with
inequality
me.
when you did that?
I see.
So-
Now I want this to be even more negative. Yeah.
Did the inequality change when you made that move?
I don't think it did. It shouldn't have, did it? I don't think it did.
No,
I think it's I think it's
doesn't.
still x is less than a negative.
because it's a decreasing function, so it has to be less than in order to.
Yes, so this has to be
Food
less than this
matchup.
regardless. Yeah. Nice. Slayer says I found a lot of channels like yours during the pandemic, but obviously not all of them stream anymore. Yeah.
Okay.
Still made a lot of great friends
Got
though.
one
That's cool.
more.
Yeah. Pandemic was a fun time, man. Thanks.
Got one more.
Eduardo subbed again, dude. You didn't spell subbed right though. It's okay. What's up? What's the other one? Seth. What's the one more we're
started
doing?
with? So same word's not problem, but I'm going to change
Same
the
one.
end result, and then instead of
Okay.
the start result. So 27 times 2 to the thirds to the ads
Yes.
is less than equal to
Okay.
32 thirds.
32 thirds. Uh-oh.
The reason I did that is because now it's not going to be nice anymore.
All right. He says no more nice problems.
Just quickly before you crack on.
Yeah. What's up?
What's
up?
If everybody on YouTube could please smash that like button, and then we
Oh, yeah.
can get some more people.
Smash that like button. Smash
I really
it.
hate using that phrase, but you know, just
Smash
Yeah,
that. You know when they do it, like smash that like button, subscribe, and yeah.
we're not quite that mental, but
Yeah, but it works. That's the problem. That's why people do it, because it works. Ugh, it's annoying.
this person's teaching maths. You won't believe what happens next.
You won't. Bankers hate him. This one quick trick to get money.
Anyway, yeah. So if everyone could please press that
Yes.
like button, so we can get some more.
Or you can do it on Twitch too. If you, Slayer says I'm not on YouTube. That's cool. If you're on Twitch, yeah, just give us a little,
either or.
a
Yeah.
follow. A little follow. Follow's nice. Okay, let's do this out a little bit more. We're almost there. 2/3 of the x less than or equal to 32. I'm gonna write 32. I know 32 in terms of twos, right? That's like 2 to the 5th.
Uh-huh.
Oh, but I see. This is not fun. This is 3 to the
Because
4th.
we know 16 thirds was nice.
Watch
Now
this
there's
math
a
before it
dip
gets
in the way.
banned.
So it's
Yeah,
gonna
let's
be
see.
2 times 2/3 of the
Yeah.
ads now.
So this is
2/3
2/3 of the x is less than or equal to.
Nope.
Sorry, to the x, not to the 3. Sorry, I messed up. Is less than or equal to 2 times 2 to the 4th over 3. The 4th, and this is 2/3 of the 4th.
Until that happened. Not 2.
Damn. Oh, this is dirty, dude. Oh no. What are we supposed to do here? Yeah, we messed up,
This,
dude.
this is your moment to do logarithms. I did that so you would be able to teach logarithms too.
Oh, so I have to use logs for this one, you think, yeah?
Yes. Here's your challenge. Can you? Is there another way?
I don't know what the log rules are with inequalities. I know with regular things, right? If I divide or multiply by -1, I gotta switch
That's
them.
why
but-
this was nice. That's why they made this thing nice, because it's known to be mean.
Yeah, all these questions,
There's
all these earlier
inequalities.
questions, we didn't have to deal with logarithms at all. We were just getting things to the same base and comparing them.
Which is
Just
why
so
I said,
nice.
is this possible another way? Which
I don't know, man. I
It's
don't feel like
not
it
what-
is. Do you think it's
logarithmic
possible
rules
another way?
I was saying no because I made the 2 because I made sure there was an extra
Okay.
extra yup in this. and
Well, let's
that,
just try
so
it. We can
wouldn't-
always graph this. Man, can't we? All right, so let's just log both sides. Let's do it. We're doing
Log
it
of
live.
what to both sides? Are you doing log base 2/3?
I'm doing
Or-
log of something. Log base something. You are right. It could be log base 2/3.
Oh, can I
We get
let me
to
ask you this? Can I
We
ask
get to
you
choose
mention
whatever
about
base we
2/3?
want.
Can we do? Let's fancy this.
What do you want to do?
What
You want to do log base
when-
2?
What happens? Is there a logarithmic rule for multiplication? Is it just break? If the inside is multiplication?
Yes, there is a rule, right?
What's the
Log of
break?
something times something is log of that plus log of that, right?
Then this is solved.
Okay,
If
well, let's see.
the inequality didn't do, but the inequality we know is messy.
Inequality is gonna mess stuff up.
Since that's times 1 because 2/3 of 2/3 is 1.
Yeah, we like this. This is 1.
That's 1 is something. We don't know what's going on here.
Yeah, this is some
Is it
weirdo.
less than equal to, or is it something else now because we changed it?
Well, I think what we're gonna do is we're gonna find a number and then we're gonna like plot on the number line. That's what we're gonna do.
So let's put a box at the moment. We don't know if this is actually less than equal to the moment.
Yeah, let's just put box.
I don't.
Let's just
I don't-
box.
I can't
Yeah, we're
say
gonna do
it's
like less
equal to.
than, greater than something.
Yeah, we can't say.
We don't know yet. We shall find out though.
The only annoyance is log base 2/3 of 2.
Correct. This is
Not a fan of
okay.
that.
This is log of base 2/3 to the 4th, which again, this just comes down. Nice. And then this just goes away. Okay. So we have x, some sort of inequality. And then we have the log base 2/3 of 2 plus 4.
4. Yep. So positive 4 there.
Okay.
So in some method. So what we could do, let's ask this system now. If I were to put that mess on the right end to the machine, to our
I mean the
function
calculator.
machine,
Yeah.
no, to the function. I've described the function of the function machine to this function.
Okay. Okay.
Into what would the result be if x was equal to that? What would it be in this?
Oh, you mean plug it in right into here? Okay.
Yeah, but I first want to know something. Do you need me one piece of information?
What do you want?
What's the log base 2/3 of 2 as something?
I don't know if that's anything nice.
No, does WD decimal? I just want to know the rounded because I need the number so I know what.
Oh, okay. Well, here, yeah.
Not another
So,
number.
yeah, we can do. Wait, let me turn on
using
math
funny-
mode. I think there's
using
like a math
tricks.
mode
I
here.
just need to have a reference number.
I already have math printed.
I don't know if that's less than or equal to 1. I don't know what it is to in relation to 1 or something.
Yeah. Yeah, let's look up log.
Well,
Is there a way to do like log base here? Oh, here we go. Log
yes,
base.
you can do. Base,
There we go.
On base 10 over 2. Ooh, that's nice.
Isn't that kind of cool? Yeah,
What's
that's
that?
nice.
Just
Really
write
good.
that out somewhere so we have it.
Negative 1.71.
Write that out somewhere.
Approximately.
And then let's put that thing into log base 2/3 of 2 plus 4 into the function. Into the
Okay. So I had 2/3, right? To the log base 2/3 of 2
yes,
plus 4.
2/3. It's not 2/3. It's 2/3 to the x, and we had it set to 32/3, I think, right? No,
We can just say let's just say 2 to the 5th over 3 to the 4th. And then we had it what? We
what
had
is
it less
that in
than.
relation? So what's that value in relation to this stuff?
Yeah, let's see. So this is 2 to the 5th over 3 to the 4th, right?
Yeah, so we're about to
Nice.
maneuver that.
Wow. Oh, thanks for the follow, dog. Luca 8.
And
Okay.
Based on that, time to do some fun.
So if I ever have a number to an exponent plus exponent, then I can split this into 2 different exponents and have them multiply each other, right?
Yeah, before we multiply, let's divide that over if we can. If it doesn't, because we divide, it's gonna flip over and destroy, cancel.
Oh, you want this to like come over?
Well, that can divide over and cancel the stuff on the left now.
Oh, you're right. You could.
We just made a 2/3 to the 4th on the left.
So we
but
could get rid of
cancel.
this, and so then that's 3 to the 4th over 2 to the 4th. So then this
Oh,
goes
hey,
away.
Josh, you're late. See?
Kiss. Wow, I got a drink. Thank you, Sam. Okay. So 2 to the 4th cancels out the 2 to the 5th. So
Josh says he's late. I don't know if we
that's okay.
overdid his problem or not, or if he
We'll give
solved the
another one.
problem.
Plot twist: it's not water.
Plot twist. Dr. Gold's just chugging vodka on the stream.
And now we're just proving it's okay. That's easier to do.
Mm-hmm.
We know log base.
Oh, this is
2/3
just
of
2. This is just 2. Won't let you sub for some reason?
Oh,
Oh,
it is.
that's whack.
Oh, so there's equality, good. So we know that's 2. Okay.
Okay.
Now when we play this next card, go down to the bottom so I can see the result we want. See all the numbers. So down to where you had the number. Okay. So yep, right there. So let's say, okay. Do them this in a word.
I think it
Well-
stays as less than, man. I think it does.
I was gonna do
Right.
1 and then all that, and we have an idea. What? So 1.
Oh, wait.
We know that 1 is less than that. We know 1 is less than negative 1.71 plus 4.
We gotta get you your 3-year
As
back,
you know, the
Sam.
2 is so we might rather use 2. If we said 2 into this, 2/3 of the x, so that's less than that. There we go. And then if we put 3, if if we did the other direction. So we do 4, and 4 is also less than that. Oh. What? Well, logarithm's an opposite function. Forgot that meant that too.
It's an opposite function? What does that mean?
It's an inverse function of a logarithmic is an inverse function. It's
Endar says, is this just not simplified to 2/3 of the x is less than or equal to 16 over 81, and it's an equality at x equals 4? Is that true?
This is a logarithmic function is a opposite function of a exponential function.
Okay, so if one's increasing, the other one's decreasing. Is that what you're saying?
Mostly.
Yeah, this was right. We had 2/3 of the x is less than or equal to, yeah, it was 30. 2 to the 5th is 32. It's 32 over 81. So it's not quite nice, right? And then we found a number. Let me think here. I think we want it to be greater than.
And why is that?
Because in order for this to be smaller than this, right? This is a decreasing function. I want this to go up. Right? Oh, yeah, no, that was the original. Yeah. No, yeah, sorry,
original,
yeah. We started, the original question was this. You're right. This was a very easy one.
Original was nice.
Yeah,
The
original was
original
easier.
was niceness.
Yeah, we're going into like hard land. Yeah, I think we want x be greater.
And
So you're right, because this is an opposite function. Okay. So x should be greater than log base 2/3 of 2 plus 4. We can also let's try putting this into Wolfram. I'm just curious, you know. Probably ask Wolfram to do this, right? So what was this? 2 over 3 to the x is less than or equal to
1581st.
32 over 81, right? 2 to the 5th over.
Here.
Let's just do that. Let's just do it this way. Yeah, it's greater than.
Oh, there you go. So
Yeah, there you
that's
go.
greater than
That's greater
that
than.
amount.
Oh, nice. Cool. So I'm great with learning math from textbooks, videos, etc., but I'm really bad with spatial stuff out in person, like estimating distances when I'm out walking. Oh, that's cool.
Ready.
That could be like have you ever heard of Fermi problems, Slayer? Darth?
So let's we got one more in here that I'd like to at least do before we get into anything else.
Okay, what's up? What else do you want to do?
The expression mess with imaginaries. You remember that one from Swap?
Oh, yeah, I know which one you're talking about. The one that Saha
yeah, we need to
posted.
get that one.
Okay, let's try and do that one. No, we'll try and do that one.
That's
Swa
the
just
one I
like
thought
came
about
and
with
just
a chance at,
dropped all
but,
this like
maybe
chaos
not.
on us. Slayer Darth, estimating distances while you're out walking, that's interesting. I think the best way to get good at that is to just do a lot of walking and then maybe reference it to, you know, a pedometer or like Strava. I love Strava. So you can kind of have an app to see. Oh, we did your question, Adarsh. we literally did your question first. I'll give you a point for it, but
You already died yours.
yeah,
Yours was first up on bat today.
yours was the first one today, and we basically did all of it. But I'll give you a point anyways.
Show the screenshot. Show him though. He missed
Yeah, I'll
it,
show
I
him.
think.
Where was it? Where was it? Was it?
I think he missed it.
It was this. Yeah. Well, we could have sent a screenshot of the work.
Yes.
Yeah, we can show that. Yeah.
Oh, it's definitely.
Yeah. Here. We'll send a screenshot of this.
And if you want to show him the other cases too, you can.
Well, I don't think he needs the other cases for
I
his
know,
class.
but
It's like I don't drive, but my parents are able to estimate the distance of car to car to the curb in yards. I don't think I can estimate things in yards. Yards is such a weird unit.
It's a
American
British
unit.
thing.
Yeah.
Yeah.
Yards is British?
Yeah.
Oh. Yeah.
really?
Yeah, it's like three feet, I guess. Yeah, the
feet
Brit.
to yard, but that's a British thing, really? I thought they use
Yeah,
meters.
Yeah, do
No.
the British use feet?
That's a European thing.
Oh, the Europeans use meters.
Metric is a recent development. I grew up in school having both systems in place.
Yeah.
But then if it's more real world stuff, it's feet and inches.
Interesting. And then they use stone for
ten-
weight.
Ounces, pounds, and stones.
Ounces, pounds, and stones. But you're saying it tends to what? What does it tend to?
It tends to be only within sort of scientific communities that use metric measurements.
Yeah. Yeah.
If I walk into a shop, I don't ask for 500 milliliters of milk. I ask for a pint.
Ah, yes, I'll have a pint. Hiss, it's Tuesday, isn't it?
I won't go in and ask for what would it be? Oh shit, what's half a pound in kilograms?
227 grams?
Yeah, I'll just say half a pound of mince.
227 grams, yeah.
Now this is messy. Sine of x over 2 plus 2
Oh,
sine of
this
x
is
over
so
2
messy.
plus I tangent of x over
Mhm.
1 plus 2I sine of x over 2. If that is real, then the
If that's
set of
real.
all possible values of x is what?
So anytime I see I on the bottom, I want to instinctively multiply by the conjugate to get
There's
only
I
I
on
on the
the top
top.
and the bottom, which is annoying.
But I only want it on the top, I think. Because I
Yeah.
don't want to. I don't want to have to deal with is that
So
divisor
what we
like
can
doing
think about
things.
first, what makes imaginaries real? What makes this? What would make this real?
What makes imaginaries real? I mean,
Well, yeah, we have to
just
it's-
multiplying
it's
by other
imaginary
imaginaries.
time is a function of trigonometrics. So what
Yeah.
makes those things real?
so I times I will get me a real number. Give me -1, right?
Well, we're going. Oh, so what's gonna make? But it's multiplied by tangent of x, not by anything else.
Yeah. So,
So what
here's
makes
like the
that
general Let's say, for instance, we had 4 over 1 minus I, okay, and was
Yeah.
equal to a plus bi. Like you wanted it in this form, right?
Yeah.
The way you would do this is you would multiply the
I've
top and
done that,
bottom
yeah.
by
What I'm saying is what makes something like I times tangent of x real.
We'll get to that here. Yeah. Let me just show the kids who haven't seen
that
this
was
before.
the first thing. Is just like trying to think what would make this even real to begin with.
This is also a trick that happens all the time with square roots. So if you multiply by this, you end up getting this is the same thing as a minus b times a plus b, which is a squared minus b squared.
Yeah,
Which in this case-
I've seen that in more spots than just that though too.
Yeah. But watch
Also
this.
seen in limits with square roots.
Mm-hmm. So this is 1 squared minus I squared. But remember what we said was that, right? I times I is equal to
Is
-1.
what?
-1.
The
So-
yeah,
So minus -1 is +1. So this becomes 1 squared plus 1, which is equals to 2. Yeah. So that's the nice thing is the denominator here now becomes 2. And then this distributes in. So you get 4 plus 4i all over 2, which is the same thing as 2 plus 2i.
equals 2.
Which is in the a plus bi form that they like to use for imaginary stuff. So yeah, we do the same thing with square roots. So if you ever have, for instance, 3 over 4 minus the square root of 2, you'll multiply everything by the conjugate.
One
so
thing
that'd be
I'm not this. No,
Or you
this
can
one is
finish off?
not gonna be.
I think this one is going to be a conjugate. Watch.
Yeah.
'Cause then-
What I'm saying, this is not gonna be nice when you try to multiply them on the top.
It's not. You're right. It's going to suck. But at least we'll have like cross terms.
Now that's not the mention of square roots I was referring to, but
Yeah. But this is the way to do it
be-
because once you get this
what I
squared,
was re-
this goes
yeah,
away.
is find the limit as is like a limit with a square root on the top, and you're just trying to multiply it to get this to not have to deal with the square roots as much
Oh, okay.
in the places that make the bottom annoying.
I see. Yeah, you could do that too. Okay, but for this one, let's just start. Let's start by multiplying. Let me start. Let me pull this down.
You don't want.
Why do I want? There we go. Be nice. Okay. I'm gonna start by multiplying by 1 minus
minus 2
I sine of x over 2.
Yuck.
Yuck. Yeah, it's pretty gross, honestly.
And this is not even a wait, you forgot parentheses though. I'll mention
I
that.
will. Yeah. You're good. You're right.
It's like this doesn't even have anything nice with binomial theorem either to do. Yuck.
We'll see. I'm thinking the sines and the cosines will start doing stuff. Also, like,
Oh, yeah,
I
they
see
do.
some half angles, right? And then I see a regular angle,
have to get
which I can
there.
also think of as regular angle and double angles. What's up, Recky? Okay, so these
Okay,
things
so
multiplying
one
by each
times
other.
So top first. So 1 times everything is nice. That's just itself.
Yeah. This just comes in and goes bing, bing,
The
bing.
negatives are nice, but the rest are not. No.
Well, yeah, so let's see what we got. So foiling this out, you get
All
the
the
same
ones.
thing, which here, I'm just going to copy it in because I don't want to write all of it.
Well, we don't want to top E because we want to think about.
Well, I want this at least,
We
right?
know. I was just trying to think because like
We will at least have that, right?
if you have like A plus B times,
And then minus, and then this is going to
something, then
be
you're going to have
2i, and look at this, this is sine squared of x over 2. Because you have a sine of x over 2 and a sine of x over 2.
One first though. Minus parentheses drip.
Sorry, what?
Minus parentheses drip. And then you're put in the that way you can just minus.
Sorry,
out
say
and
it again, Sorry, I didn't hear. Minus parentheses what?
parentheses and then and then your stuff inside. That's just to take for the minus and one.
Oh, I was just going to do it throughout. I was just going to do minus,
It
minus,
just,
minus.
and then we can look at what subtracts and etc.
Okay, fine. We can do that. That's okay.
I just did that just to.
Yeah. Okay, that's okay. Alright, so then this is
we keep everything grouped as we move.
2i sine of x over 2 cosine
Well,
of
there's a
x
sine
over 2.
cosine pair there.
Yeah,
So
we like
that's
that. Sine cosine is nice. We know what that's going to turn into. And then,
Plus.
what is
Ooh,
plus
there's a square. There's
2i squared, right?
Negative
So
2,
plus 2i squared, which is going to be negative 2. And that's tangent of
sine
x,
tangent.
sine of x over 2.
And then the bottom is also doesn't equal yet.
And then we haven't done the bottom yet, but that's going to be this squared. So that's going to be 1.
1
And then it's going to be minus this thing squared. So it's minus
minus
4
I squared.
I squared sine squared of x over 2.
And then a line, and then you're done. And then your bar. And then your increase bar.
My increase by what bar?
Your increase bar. Denominator bar. Yep.
Oh yeah, this needs to like extend out a lot more.
Yep.
This became a big girl fraction
way.
really quick. Okay. So some nice things here. I squared is the same thing as negative 1. So we can get
sign
rid of this
switches.
and put this as a positive.
Let's
right?
do the other one while we're at it. There's another sign switch on the top.
There's another one here, right? This one is going to go away, and this is going to become negative. So we're going to get rid of this.
The next one I care about is going to be that sine times cosine pair.
Yes, this is the same thing as sine of 2x, which is just going to be x actually, really, right? Isn't that how that works? So I think sine theta cosine theta is equal to sine of 2 theta. Is that true?
When you check with my sheet beforehand?
Yeah. Do you have a sheet? You have a formula sheet?
Yeah. I get it.
I think this one is sine of 2 theta.
I don't.
Oh, I messed up. What's this over 2? Okay. Thanks, Anthony.
Second. There.
Mm-hmm.
And then we're looking for what was it again?
Sine of 2 theta, basically.
Sine of 2 theta is 2 sine u cosine u.
Yeah, so there's an extra divide by 2 here. Yeah,
No, there's
Shantra, you
not.
can do yours next.
Yeah, because here, no, you're good. You know why?
Well, yeah, this will
It's
cancel.
2i,
Yeah,
so
exactly. Yeah.
There's the 2.
Yeah.
So we have
So
to have a 2 cosine.
if we replace
2 sine
theta here with x over 2, now it's sine of x over 2, cosine of x over 2 is equal to sine of 2 times x over 2. Over 2.
No, and
2
then
times
no
x over
divide by
2 is
two,
just
no divide by
x.
2. No, you don't need to divide by 2. You have the 2 from the 2 I pair.
Yeah, I'm going to show that. Yeah, okay. So if this 2 is here,
that
this 2
two
is here, and this
equals it.
cancels. Yeah. Okay.
Yeah.
So this is going to go
This time-
away,
So that 2 goes away. We just did the I, right?
and then this became sine of
Oh, and
sine of
Chantrix.
x.
Oh, he has another.
Yeah, we'll do Chantrix as next.
Oh,
and then
yep,
this
he
is,
does. Hey, guess what? It's another geometry.
well, it's 22 at least, so it's not super hard. Hopefully. Okay.
Oh, we don't have that yet.
All right. Let's see.
That's sine of x. Okay. I sine of x, not It's I sine
Sine
of
of
x.
x. Yeah. Well, the i's still there. I haven't gotten rid of it yet.
Can we do this tangent times sine stuff over on the other sides yet?
Oh, I don't know about that.
Can we? What can we do with that? Because we can probably. Let me look at tangents.
Does tangent have identities? Is there a double angle for a tangent?
Yeah, there is, but it's I hate it. 2 tangent over 1 minus tangent squared. Nope. Not gonna touch that.
Let's just leave it for now. Maybe it'll pop out at some point.
But it's not. I'm not even gonna touch it. It is not. I have the half handles, which tangent. Ooh, that's better. No, that's better. Not good one though. Nope. No. What about it? We can factor this I out of there, so we just have to think about it later. If we need to.
Yeah, we'll get to it. Plus minus 2 tangent of x sine of x over 2. This is such a mess.
Yeah, it is.
All over. My thing is bendy. 1 plus 4 sine squared x over 2. Okay, let's maybe go to the original question because it said it was real. Okay. If it says it's real, that tells me that the imaginary part has to go to 0. Okay? That tells me this part has to be equal to 0.
That's.
This simplifies our question, right? So the nice thing about imaginary and real parts is you can separate them out and deal with them on their own.
That's what I was going to say. Factor an I because I actually know that the tangent of x minus sine squared x over 2 plus sine of x is imaginary in some way, shape, or form.
Yeah. Right. Okay.
And we need to know when that is imaginary.
So we need the tangent of x minus 2 sine squared x over 2 plus sine of x has to be equal to 0. Also, yeah,
it's not
good.
0 necessarily.
We also have some restrictions on this, right? Because we can't have this being equal to 0.
Let me say this. That is unequal 0. I will not confirm nor deny it's 0. Because it should also be imaginary. It just be I, and then we have it fixed. I times I is
okay.
1. As long as it's imaginary, then we're good.
Okay.
Imaginary with no extra plus.
What do I want to do with here though, Seth? What do I want to do?
We want all possible values of this x.
So
that thing should also be imaginary and be completely fine. So we have 2 cases now.
Well, I could write that tangent of x is sine of x over cosine of x, right?
Yep. This is 2 cases.
When in doubt, multiply everything. Turn everything to sines and cosines.
Can we do something else then? While we're at it?
What if we multiply the whole thing by cosine of x? I see something. I think I see something, Seth. Watch this.
Sine squared of x over 2, sine of x over 2 is something we can just maneuver.
Yeah, watch this.
And get rid of the...
I'm going to multiply both sides by cosine of x. Right, so this is going to kill off this, but then it's going to like give one there and give one there. This goes away. So now I have sine of x.
In one case, it does away.
Minus 2 sine squared of x over 2 cosine of x.
And here's the plus sine.
Plus sine x cosine of x. We like sine x cosine of x. Equal to 0.
0 or imaginary times cosine of x.
Or an imaginary. But there's no way this can be imaginary. Sine and cosine. No, sine and cosine only gives you real values.
Minus sine squared of x over 2 plus sine of x should be imaginary if this was in the non-real plane.
Yeah, but we're going to assume everything's in the real plane.
Why are you assuming that?
Because I don't want to be sadistic. I don't know.
We can't assume this. It's all possible values.
Yeah. Well,
we got into a draft here.
Well, let's just solve it simply and then see something. This is nice. Sine of x, cosine of x. This is 2 sine. This is. Sorry, what did we say this was? This is sine of 2x over 2, right? I wonder if I want this to become sine of 2x though, or if I'd rather everything be the same power.
Let me see. I'll give you a piece of information. Let's see if it helps. Sine of x over 2, because we know that sine squared of x over 2 is the same as sine of x over 2 from sine of x over 2.
Wait, can't we just pull a sine of x out of this too, man? Isn't there a sine of x in every term?
Not until I move it. Not until I maneuver one piece. Sine of x, I might have, oh, please, no.
Yeah, no, he's got a good point here. Watch this. Okay.
I don't want to do the net. I don't want to do what I'm about to say.
Sine squared of x
Let's
over
not
2
do
is
that.
1/2 1 minus cosine x.
I
So
don't
now
want
this
to
is,
It's,
look at this. This is cool stuff.
oh, it's a squared. Yay.
Yeah, we like that.
I'm happy it's squared. I'm not
Yeah,
happy,
we're
it's
happy it's
squared.
squared.
It wasn't just a square root. It's a plus minus annoyance.
Mm-hmm.
I'd be annoyed if it was okay.
Okay, so this goes away.
That's
nice.
dope.
Goodbye. Okay, so now we have sine of x
Minus 1 plus
minus
cosine of
1
x.
plus. Wait.
Cosine-
Wait, this
nope,
is still attached to
I
this. Still
forgot
attached to
about
this. Yeah,
it.
no.
Minus cosine of x plus cosine squared of x.
Yeah,
I just
wait,
go
sorry.
for that.
Sorry, it's minus sine of x minus cosine of x plus cosine squared of x.
Plus sine cosine of x is 0 or imaginary times the cosine of x from before. Okay.
Close.
You ready for this to be nice?
How's it gonna be nice?
Let me find what I want. I'm thinking this could be nice depending on cosine squared of x is
1 minus sine squared.
in respective to sine. So there's respect. We can switch that over to something else if we just desire. Is there a rule that says about sine of x minus cosine of x? Is there a rule that says does?
I don't think so.
Sort of hope I'm looking to see if there's anything that. There's a double angle, and then there's a identity that there's not. Hey, sheesh. The rule that would just meet this much better.
Unless we made a mistake somewhere. Could have happened.
I wasn't expecting it to be nice. I knew that much.
Yeah, we knew it wasn't gonna be nice, but you know, every dog has his day. I tangent of x, and that was that was 2i sine cosine.
Okay. I don't want to put that in an entity. That's not helpful.
Well, let's look at the answer choices. So they say n pi.
Which NPi is the rotation machine. Is our rotation machine.
Oh wait, they just want to know what x is, bro.
Yeah, that's what we've been saying.
Oh.
What's the possible ways of x? We've been
Oh,
trying to
okay,
do
sorry,
cases.
my bad. Okay. So wait, let's see. If x is pi, does this make sense? Sine of pi would be 0. This would be negative 1. This would then be positive 1, and then this would be 0. So it does work. NPi does work. I think the question is, what are the other ones that work?
Because we still have to prove imaginary cases too. The imaginary case is probably what's in a braid. So why would pi work? Why do we care about pi? Because pi is not an answer choice.
It is. Well, it's NPi.
No, it's not. Just NPi plus the.
Oh.
NPi is just our friend that says, well, I can move it anytime that I want around the loop.
Well, halfway around the loop.
We want to know what pi over 4, pi over 8, and 3 pi over 4 does to the machine.
I agree with that, actually, yeah. Okay.
Because the other
pi over
stuff,
4,
that's the rotation.
That's square root of 2 over
Oh.
2 minus square root of 2 over 2
You know those.
plus,
You know you
plus
need
1/2.
that. They-
Plus 1/2, right?
not
This
right-
actually doesn't
oh,
work. This doesn't
one.
work.
Well, it might if it's imaginary. The imaginary case might work. I don't know.
Right, this one doesn't work. Okay.
I'm just relying on that doing things too. Oh, is real? What do you mean, Jeff? That's not helpful. Is
Yeah,
real
it's
when?
only only real if this whole thing equals 0 though, because this was the imaginary part of our expression.
Yeah, what with the others? Pi over 8 goes in. What happens?
Oh, never mind. You're good, Jeff. Yeah.
So
we-
you
what we
want
did is
something- you need
we
the-
multiplied by the conjugate, Jeff. We got
You need
something
unit circle
nasty. We pulled out the I stuff, and then we set it equal to 0.
You
The
need
technique
you
we're
need-
using is correct, but do I need
you
something
need
about
unit
stuff?
circle stuff.
No, I know what all the values on the unit circle are.
Do what's
I mean,
pi
it's
over
fine.
8 then?
I don't know that one.
You need unit circle stuff because I know I have pi over 4.
I
And
know
we
I know
the
that,
half-
and
we
then
got
I know
halfway
3 pi
point
over 4.
markers.
Yeah. Oh, what's up,
Pi over
Obi?
8.
Thanks for the raid, dude.
No, that'll help me.
Well,
Pi over 8 's the right
let's see.
time,
If it's
and
3
then
pi over 4, if it's 3 pi over 4, this is square root of 2 over 2. Then this is plus square root of 2
15
over
degrees
2.
of the calculator for here. Yeah.
And then this is plus
Pi over 4 and
1/2
angle formula. Yeah.
minus 1/2. This one doesn't work either. Trig. Pi over 4 in the half angle formula.
So
What?
did 3 over 5? Did 3 pi over 4 work?
No. I
No?
don't think pi over 4 is gonna work either.
Pi over 4 we already did. We don't care about it anymore. It didn't work.
Pi over
Did
4
3
didn't
pi over
work.
4 work?
I don't think 3 pi over 4 works either.
Why?
I don't know, it just doesn't like us today. Wait, no, it does actually. Sorry. Because this is square root of 2 over 2.
Negative square root of 2 over 2.
No, but minus, that's positive, right?
Oh, sorry, I reread. Yep, pi over 2 pi. I reread.
It's not gonna work. It's not gonna work.
Minus negative. Oh, that's plus. So that's already.
No, it's already too big.
And then sin ats, cosine ats, we know is 1. That's 2. Nope. What about pi over 8?
I don't know
Oh,
about
it's
pi
still
over 8.
imaginary, but it doesn't work. Which is still imaginary too.
You know what I want to do? I want to take
this.
I want to take our original expression. I want to just take this and just have Wolfram solve it analytically for me. I just want to see if we get it right. So what was it? It was tangent of x.
You might need to write something down. So you
Tangent
can
of x
copy.
minus 2 sine squared of x, right?
Sine squared of. Is it ats though?
Sine squared of x over 2 plus sine of x.
Is that it? And then the 0 of that. Yep.
Yeah.
Okay, there we go. So all the cases.
Oh, that's not really nice.
Well, it's not. It's not supposed to be nice. Try imagine. Now let's fire for the imaginaries now in here.
What are you talking about? The imaginaries, dude?
Imaginary notions
What do
in
you?
here.
I don't think we want to use the imaginaries. What? So
Well, we
imaginaries.
do. I times something's I times something is real. So it could be I.
But how can sine and cosine and tangent
If we're
give
in
me?
the imaginary plane that we've talked about,
Oh,
that we care about using.
but x is a real number.
Well, it is. Can it be imaginary though? If it's
No,
if it's in the imaginary plane when
Well-
I push it
I don't think so.
then this is a D then, right? This is answer choice D then.
I think it's answer choice D. You tell Suave it's answer choice D, because we're not getting nice stuff. I think it's none of the above.
Okay, let's try this one then. A rectangle with dimension. Ugh. Okay. Okay. Here's the this one. A rectangle with dimensions 100 centimeters by 150 centimeters is tilted so that one corner is 20 centimeters above a horizontal line, as shown. The nearest centimeter, there will be a height of vertex F Z above the horizontal line as headed at centimeters. What's the value of that?
I think this is cool. So they want to
Okay.
know. They want to know this.
Okay.
Yeah, right. Wasn't that Shantrix's last question with the? Wasn't his with the cube?
So,
I really liked that cube
let
question.
me
That
start
one
with
was a
computer
bender.
version.
This one was a bender to like do this one, but we got it. I was so happy we got this one.
So let me start with an easy thing I see, a start thing I see. I don't know if it helps or not. I know that floor line there. I know how long that floor line is.
Okay.
Or at least I know how to get to it.
Well, I know we can use Pythagorean theorem because I know this is
Yeah.
100.
What I'm saying is, yeah, I was wondering if that helps or not. Knowing that line, that floor.
I'm like tempted to figure out this angle and then treat this as a rotation about this point. And then like do it in polar coordinates and then get Cartesian from it. What's up,
You have
Dilos?
to do
What's up,
polar, though?
Pogix? Pogox. What's up, Pogox? Do we? I don't know.
Oh, I see something interesting. Well, can't I move that line a little bit to the left over here? And make it a right triangle geometry idea?
You want to do this?
And make it right triangle now? Where Z line, the northern line, and then that.
I like that. Yeah,
right
that's
over-
kind of cool.
Can I do that?
So you want to put this here. You want to put this here. And you want to say
Yeah,
this is a
Can I
right
do that
angle.
now? right
I don't see
angle?
why not. I don't see why not. And then we know
So-
that this right here is 150, right?
We know that. Do we know either of the others? Well, we know. Well, yes, we do. I think we can.
I think we can get this angle from like this angle. Are they not the same?
What I'm saying is, I think we can get the side too, but I'm trying to think of, because I also know something. Let's copy that. Let's copy that and rotate it, and put it up on the other side.
Sorry,
Because
where
you know
going?
it's true on the other side as well.
You want to put it over here?
Yeah, we know it's true on the other side as well, and there's that triangle repetition.
Oh, okay.
Oh,
Cool.
what's it? Oh, so there's the two. I know.
One sec. Let me draw it again. Sorry.
I know a length. I know so we know that's going to create two triangles there, the top and the bottom. The top one we know the lengths, the sides of.
Do we know all the side? I don't know if we
so
do.
we know the bottom one because we know the opposite version.
Well, yeah, I know this is 20. This is 100. So then I can figure
What
out
I'm saying is
this.
we know the bottom one, so we know the top version.
Oh, I see. Are we allowed to say that this angle is the same angle as this angle?
Well, do you want to make it harder or want to make it easier? Once we can assume it's not true, and then we can do different stuff.
Well, I want to make that true for myself.
Wait, sum to
Yes,
180.
they
Jeff
sum
says
to
it's
180.
true,
Jeff
which
says
is what
they're
I was
true.
doing with.
How are they summing to
give me a
180?
green line up top and an orange line up top, and just so we can finish that off because we know that.
What do you want to do, sorry? You want a green line
A
up
green
top?
line and an orange line, so we get a fourth triangle too.
Oh, I see. You want to do this. Okay, yeah, one second.
Because I know that. I know what that top thing is gonna be. I know what that top triangle's line's made of.
I see. Wait, well, sorry. Let me just do this. Like that?
Uh-huh. Now, I want to make one claim, and I hope this is gonna work. Let's find that bottom side of that Pythagorean theorem triangle down there.
Yeah, I agree. Let's do it here. I'm clear this out
You
so
know,
we don't.
of that. No,
so
the
we don't-
bottom ones. We don't know the top one without the bottom. So let's do the bottom one.
I just want to get rid of this.
That's
so
what I'm
it's
worried
not, like,
about.
Messing with me. Okay.
And I,
Yeah.
I was wondering, is this a 30-60-90, 45-45-90, or something else? So it's fine.
Well, it's not this one here is this one right here is not any sort of nice 30, 60, 90.
Do we know? How do you know already?
Here, I'll zoom out a little bit. There you go. That's a 5-to-1 exactly, right? Yeah.
So it's not. No.
Okay.
What is?
Let's just call this thing like A, for instance. Right.
A sign is 1/5. Okay. No.
A squared plus 400 is equal to 10,000, right?
Yeah. Oh, it is a special. Yay.
It is a special
It's just,
triangle?
oh, it's not a special though.
And I was trolling.
Yep, that's a special.
I was trolling.
It's a mess. Oh, it's square root of 900. Ooh, thank you. That's a number I want though. It's square root of 9. So that's absolutely. Let's push
So
some
this is the
stuff
square
out
root
of
of
it. I
9600?
see a 10. I see a 2. I see a 10 and a 4 already. Let's simplify it before we put it up there.
Oh, you want to simplify the square root of 9600?
I would rather not be that. I know there's a 10. I know there's a 4 in there.
Here, I could
know
make
that
this.
I know there's a 4 and a 10. That has to come out of it.
Well, one second. Let me break this up
Obviously, it's
into.
40. So.
This is
I
a
know there's
100
100
and a 96, which is a 10
Yeah.
and a 10,
Oh, is that?
and then this is a 2. Right, a
96 is
2
the
and a
4 I told you about. I told
Well,
you there's
here.
a 4 in there.
4 and a
Give me that
24,
line. I
and
knew there's a 4.
then a 4 and a 6.
Ah, it's not gonna be nice. There's a 6 left.
It's okay.
So it's
It's 40 square root of 6.
yeah, that's not the nicest thing ever. But I'm happy about
Could be
it.
worse. Life could be worse.
Did you see that? Pocox asked if you could zoom out.
Yes, I did zoom out. Yeah, so you can see it. Okay, that's 40 squared is 6. This side's 20.
We have this. We just want that one height, and we're done. The problem is we don't.
The issue is on
Yeah, I know.
this triangle, for instance. I only have one of the sides.
Well, we have one side, and we have some ideas about the other side based on information, right?
Well, okay, if I say that these angles are the same, right? That this angle is equal to this angle, then
X equals 60 square root 6 minus.
yeah.
what?
Sorry, well, I did it. So
Yeah, that says
100
that.
over A is equal to 150 over B, right?
What's B in this case? I don't know what
B
you're
is-
talking about now.
B is going to be this.
Okay, you have to make a claim.
This is B.
And then A is what?
A is 40 squared is
40
6.
squared is 6.
40 squared is 6.
And then A is
Okay.
your already claimed number.
So 100 over 40 squared is 6 is equal
Ugh.
to 150 over B.
and then
So B is
multiply
equal to 3
150
halves,
Yeah, oh, what? Okay,
40
you're
squared is
doing the
6. So I
No,
move
it's
this
not
down,
that, though. Okay.
and then I move this up. And 150
And
over
then
100
you'll
is
have
3
to
halves.
Simplify that more.
Correct. So that's B is equal to 60 squared is 6.
Well, B is. How do you know B is 150 though?
No.
we didn't make this, we
150
don't know B.
is this part. Oh, no.
No, we don't. It's B's not.
Yeah,
150.
no. 150 is this length, Shantrix.
B's are. We have. So B is.
60 squared is 6. Okay. So then it's 60 squared is 6 plus 20, right?
Is it though? I'm
Right?
still trying to.
Because this is
yeah,
the 60 squared is
yeah,
6, and
so
then it's plus the
that's
additional
true.
20. But they
Okay.
said to the nearest
But-
centimeter, the height is 100 plus x, and then they want to know what x is.
Yep. They made it a little bit annoying. That's it. So it's at 60 squared is 6 minus 80.
Uh-huh.
That's all they did. They just put it in a trickier form for us to do.
Right. Okay. Well, one
Plus
sec.
20 plus ats and then solve for ats. Yeah, and then we know that's
Okay.
100 plus ats.
Yeah. So
So
sorry. 100 plus x is equal to 60 squared is 6 plus 80 plus 20. Sorry. Okay. Yeah. Sorry.
Yeah.
So this.
yeah,
This
that's
goes
why I was-
away.
That was it.
So x is 60 squared is 6 minus 80. And then
Well, it didn't go away though. We can't say it went away there, friend. But otherwise,
yeah, okay. And then 60 squared is
you can't just say it went away. Is what I'm saying. Is you said those went away. So
yeah, sorry. It cancels or whatever.
Well,
I
they
subtract
don't.
100.
It's
What is this though? What is 60 squared is 6?
something we don't need. Oh, is it near a centimeter though? No, it
Yeah.
is. Well, we have it. We have the nearest centimeter right there.
Nothing
Yeah.
nice. It's 146.96.
Minus 80. So
Okay. So
what's
what's that? 66.96? So 67? Near centimeter
what is that?
67.
Ats equals what? Ats is approximately 67 centimeters. Yeah.
Yeah, x is 67. Is x 67
Ats
for
is
this one,
approximately
Chantrix?
67. Nope. I wouldn't agree with that.
You don't think x is 67? Why?
There's no units on that on your result.
Well, we don't want units on our result. They just want the value of x. It is 67.
It's not-
He says it is.
it's approximately 67. You decimaled and rounded.
Sorry, what's up?
It's approximately 67.
Oh, yeah. No, but they said to the
I know,
nearest
I know.
centimeter,
It's
what is the value of x? Then it is 67. I mean, this is whatever semantics at this point. Yeah, you're fine. Okay, cool. Good question, Chantrix. I like that. Was a fun one.
So do you want to? So we have, and now there's stuff there's only one. Let me see if there's any others. In
I
here
got like
we
another.
should-
One sec. What am I teaching this kid? Sorry, I gotta see what I'm teaching this kid. I could do like another 10, 20 minutes maybe.
You want to do a proof then, or you want to do something else?
Well, let's see. What we had other questions from Shaw, I think, right? Answer the last
Yeah.
question. Was 67? Yes. Nice. Yeah, we got it right. That was pretty cool. Oh, answer to the last question was 67? Wait, was it? Really? I think he says this one was also 67.
Yep. It was.
Oh my god, it was 67. Wow. Endar, you got great memory, dude. You get points for not guessing anything? Wait, how does that work? You mean you lose points for guessing?
Now we're doing wave functions and quantum numbers. So,
Wave functions and quantum numbers, were we? Oh,
Yep.
Jesus.
that's what's next. If you want to keep going with Jaw stuff.
All right, let me see if I can do this. If you guess wrong, you get 0. If you don't guess, you get 2. If you get right, you get 5. Wow.
Or would you rather
That's
do an IMO proofing problem? That was from from the 12th of March.
Oh, I'll repost it. Can you repost it just in the list?
It's already up there. It's up above Saw stuff. It says the following. You want to do the proof instead? I can just
Where
let
is
a and b be integers and n a positive integer. Prove that b to the n minus 1 times a plus b times a plus 2b to the nth, all the way through till you get to a plus n minus 1 times b, all over n factorial as an integer. It's up on March 12th,
I don't see it.
right above Shaw's stuff.
Oh, I see. Oh, that's your proof. What does IMO stand for?
It's the competition problems.
Oh, okay.
It's the competition problems stuff.
Sounds like a Pascal's triangle problem. Yeah. I don't know.
Which one you
yeah.
wanted to do?
Let's do
Wave
the IMO
functions or
one.
that?
Yeah, because I don't think I
Okay,
really know this one.
It's
For,
right there. Dude. This one's mess. This one I'm done with the ones I can help you with.
yeah, I don't know the
Yeah,
quantum
I-
numbers
I-
of N
I
and
thought
L
I
on
would
this
have
one.
to do something.
This has to do with just N,
And then it's all
L.
chemistry, and then it's your stuff from there.
I love chem. I'm a big fan of chem, but
It's all your stuff, all of science stuff from there.
yeah, I like science. But yeah, let's do the IMO question. That's cool. We can do it. You've done it before.
Are
You
you
know how to do
reposting
it.
something? Are you doing repost?
Oh, I'm trying to go find it. One sec.
I know where it is. I can just grab it if I need to.
I got you. International Math Olympiad is what Shantrick says.
Here you go. Reposted. I moved it.
Is this it? Is this it though, right? Is this?
I moved it down for you.
Oh, okay, nice, thanks. Let a and b integers and n is a positive integer. Prove that b to the n minus 1, a plus b, a plus 2b, blah, 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 a to the n minus b over n factorial.
The integer. So we're just
It's an
proving that something's an
integer.
integer when given a series representation.
Damn. This is like a multiplying series notation, though.
Yeah.
Right.
So we're doing a power. We're starting with a power, and then we're multiplying by a, and then a plus b, then a plus nb from there.
A plus n. Wait,
Well,
all
it's-
over
we're
n
adding-
factorial.
we're a plus the n as it increases.
P127 says IMO problems are very, very hard usually.
And this is number, yeah. So
Okay. It's from 1985 though, man. Can't be that hard, yeah. Okay. I mean, maybe. I don't know. How do we start this one? I will admit, I haven't the faintest clue what to do. Because if this was an adding series, I'd be happy with it. But it's a multiplying series, which. What's the notation
it's
for that?
actually-
I think the notation
it's
is
actually
this.
nicer.
Isn't this the notation for multiplying series?
yeah. What makes this easier is we're defining it by a factorial. It's also multiplying.
The only thing that could make it not an integer is the n factorial, no? Oh, it's just straight pi, yeah. Correct. Yeah, so these are all integers. So,
But we care about when divided by something, it's an integer.
When divided by n factorial. Let a and b be integers and n be a positive integer.
Let me
So
do.
does this happen for
rewrite this.
anything? For any integer this works out?
That's
Like
the-
if I
yeah,
say a is equal to 3, b is equal to 4, and n is equal to 5, will this always work?
and you're proving that's an integer.
Well, let's see. I'm actually curious now. So this is 4 to the 5 minus 1. And then I would say
3.
3. Then 3 plus 4. 3
and
plus
3 plus 2 times 4. Yeah.
8.
And then all the way through 3 plus.
Did I pick a
plus
bad number
n
for here?
4. Yeah. Plus some amount of n. Some amount of.
Okay.
What?
Plus 3. Well, here,
That's
let me write them out. Sorry. Yeah, you're right. You're right. Let me write out the 2s and stuff. It'll kind of make. We might see a pattern.
Why is 3 times? Why is it 3 times? Oh yeah. Why is it?
Because it goes all the way up to
Okay.
n minus 1. And n minus 1 in this case is 4. Right? And then this is all over
Over 5 factorial.
5 factorial. Which 5
4 to the
factorial is 5, 4, 3,
Yep.
2, 1.
And I see the 4. I see the 4 already.
This is going to be
So 4 to the 4th divided by a 4.
yeah, I just want to make sure this one works, and then if it does, then I'll have more faith in it. I'm sure it does. So 4 to the 4th.
Divided by 4. So we can divide that by 4.
Alright, so one of these goes away. Cool.
And then I'm going to do another one. I'm going to do something else too. Divide by 2. We're going to divide this thing by 2 as well. Because we can understand. We know that it's going to be 2 times 4 squared.
Wait, where's the 4 squared?
2 times 4 squared. Because I'm gonna bring that 4 out of that and divide that by 2.
Oh, okay. So you're gonna
This
pull.
is 32. That thing is 32 now. I just got that down to 32.
So you're gonna write
And
this
that's
as 4
and then the
squared.
4 that we brought out is now divided by 2.
This is 2. Okay.
And I see a 3 already, so we can do that.
See a
as
3
well.
going away as well. Okay, cool.
And then we have the 5, which I don't see a 5
I
yet.
don't see where the 5's gonna come out. This
Let's
is
do
7 plus 7 times 11.
times 11 times
15. Here's the 5.
there's the 5. So it's an integer now.
So it's
We just
okay.
count that an integer.
Okay, let's see what Jeff says. Jeff says we have to show that the numerator is a multiple of 1 or 2 and n, including the repeats. I think you can regroup b to the n minus 1 by putting a b besides each multiplicative term. The penultimate term, right? Penultimate doesn't mean the last one. It means the second to last one.
Okay.
Yeah,
So
okay,
let me make
then
this
this-
claim then. Let's make a claim now. So write this out again. Write the thing out. Write the thing out we're given, rather than the
Yeah.
we think about.
Yeah. I like Jeff's idea. Are you gonna distribute the b? Yeah. So we have b to the n minus 1, and it's a plus b.
A plus b, and then a plus n. Yeah, a plus 2, all the way to a plus nb. Yeah, a plus all the way to a plus. Yeah, n minus 1b importantly. Over n times n minus 1, etc. And the interesting thing with our 4 case is the 4 from the n minus 1 is found in the b to the n minus 1. Right? That's where we had that. That second term was found in our b. Or no, it's not always though. But
No, it's not always gonna be that. What's up, Mohammed? Oh, P127 solved it. This was unexpected, somehow easy. You need a bit of number theory though. What's the number theory, P127? Induction of n might work as well.
okay.
Because I see an
Now,
n
we
minus
can-
1. Wouldn't it be
one
nice
thing
to
I
just do?
see we could do.
Well, wait. Here's the question. Can we do this by proof by induction? Like, because we showed a base case where it works.
Yeah.
We did show a base case that works.
I like that hint.
Hint: if you're stuck,
I liked it. It's prime.
consider the
power.
prime powers.
This is a prime system.
I don't know what to do with that information, P127.
Okay,
But I
so
feel
one
like
thing
you
I
do.
would like to go ahead and do, is b to the n minus 1 is b times b to the n,
Okay,
right?
I agree with that.
Or no, it's not.
It's b to the 1. It's b to the negative 1 times
Yeah,
b to
which
the
is
n.
on the bottom. So, ooh, hello. That's interesting. That is interesting. Oh, that's, oh. Okay, that's interesting. A plus b times a over b plus 1. And then a over b plus 2, a over b plus 3, a over b plus 4. Okay. There's the series. Interesting, isn't it?
What do you see? What's interesting?
Factor the b out and then watch.
Okay, so you want me to what? Pull just a b out
And then
of
put
here?
it on the bottom. Right, yeah. We can join that to the bottom and you'll see things.
What's up, 1K dude? Haven't seen you forever, dog. What's going on?
Nice. A little bit
See,
at
bro.
least. Okay.
Okay, and then you
that
want to
b
put this on the
negative 1
bottom?
is a bottom power. Yep. So.
Hint number 2, since you didn't understand hint number 1. I know. I'm too dumb for number 3. A divides B
That's what I was.
if
that's
all
what I was
prime
going to.
factors of A
Now divide everything on the top by b.
if all prime power factors of A.
And watch.
Divide B.
Divide the entire top by b and watch.
Thanks, Valerian. You have a great rest of your day too, man. Sorry, what do you want to do? You want me to divide B
the
by
entire
everything?
thing on top by b and watch. Other than the first
one.
We know is
Oh, okay. So I have B. One sec. So let me go up. So I have B to the N, and then I have
we didn't.
A over
we did
B.
the end, and then we already do that. Didn't we already divide by b? On that one, or
Yeah, we pulled out a B to the minus
Okay.
1.
A over b again, plus 1.
Wait,
this
no.
time.
B doesn't divide all these things, does it?
I don't want it to. I just want it to be nice. I don't want it to be nice. Go ahead. I want to do what P127 was getting at before he got at it.
A
ahead.
divides B.
Go ahead, look at it. Go ahead.
So what do you want me to look at?
A over B
Yeah.
plus 1, A over B plus 2, A over B plus 3, etc.
Oh, but I'm not allowed to do that
And why?
because I'm only dividing by a single B.
That's fine. Oh,
Okay.
Okay. You're true. So is this the first one or what?
What's up, Teacup?
What if you weren't divided by a single B though?
If I wasn't, well then this would be really nice. Yeah.
Why do I said where B let's bring B to the end to the bottom and divide it? Let's divide by B to the end.
So what? I'm gonna write this as B to the negative
That's
n.
B times infinity amount of B's.
If I'm gonna write it as B to the n, B to the 2n.
Well, is it B to the end is being divided out, isn't it? Or so,
Yeah.
So what am I doing? So
B to the 2n then, right?
oh,
Is it B to the 2n?
you
'cause
could
I need-
pull it into B to the end. Yeah, absolutely.
And, yeah. You can pull another B to the n, right? Yeah.
Yeah,
yeah, right.
absolutely. Let's do that.
Sure.
And then divide it. Now we divide everything finally.
Okay, that's
we
just fine.
see all the A to the B's.
And then n minus 1. Dot.
And I see n minus 1. And I see n minus 2, and I see n minus 3, and I see n minus 4, and I see n minus 5, etc.
Oh. This is n minus 2. This is n minus 3. This is n minus 4.
Yeah, I see that. I see all those. I
Okay.
see all the infinity amount of n minus 1s other than the n.
Yes.
Oh,
you are right about that.
Now it doesn't divide the other painting. No. It just
Nah, but what about the n though?
No, I was worried about the n minus 1 yet. Because A over B. When I put the A minus n minus 1 to the first, then it's A over B times n minus 1. Now, plus 1.
So this was the same thing as n minus 2. And then
Is
this
it n
the
minus
same
2
thing.
though? No, it's not. I don't care. It's not n minus 2. That's not true. By saying
Isn't
that's
it?
n minus 2, you're saying that this series is not a series.
Well,
It's n minus something.
yeah.
You can't say it's A minus 2, otherwise this isn't a series anymore.
Something like this, I guess is what I'm saying. I guess I'm seeing where it goes up. Yeah. Put a 2 at the
We know
end
we
of...
see everything in there, from n minus 1 through to infinity in this somehow.
I think we should induce labor. What's inducing labor? Wait, is this pregnancy? What's going on here, guys? Okay, cool. I'm cool with all these going away. That's fine. What about the n though?
But we haven't got rid of the n minus 1s yet, because we have to acknowledge that a over b to the divided by n minus 1 is still existent.
Sorry. So we have to deduce that this is still okay.
No, I wasn't more about that yet. I'm
Okay.
saying a over b divided by a over b plus n minus 1 over n minus 1 is still a over b over n minus 1, which is a over b times n minus 1. That's still annoying.
Okay. Jeff thinks we should use induction.
I was worried about this right here that I just typed, so you would see what I meant. I'm still worried about that.
A
That's still
over...
in the existent. That's still existing.
Why is it still existing? Sorry. Oh, you're talking about... Sorry. This
Write
one?
A addition
This one?
system. You write an addition system in all these cases,
Mm-hmm.
which means you have to divide it across both of the addition cases.
Oh, okay.
It's really saying a plus
Oh, I see what you're saying.
n minus 1. Yep, you see the emptiness now. Because this is what you're saying.
Oh.
Which, this thing, it would be all, other than the from at the B case, but... Yeah. 'Cause we still have that annoyance. That's what I'm saying, it's not quite gone yet. I was saying it wasn't, I was just saying it wasn't quite.
Mm-hmm.
It wasn't quite to the point yet of being gone. But we still have that. We still have that n minus 1 in there. It's just under.
You mean
it's just been
underneath
fractured now.
under these things?
Yep.
Yeah.
Yeah. Absolutely, Ender.
Can you show the original problem? Here we go.
Let a and b be integers and n a positive integer. Prove that this thing is an integer. Well, yeah. That's the thing. We see that, but do we still see that B? We still see a over n minus 1, and a over n minus 2, and a over n minus 3, etc.
Yeah, because both
That's
of
what
these
is-
things.
Is
Both of these
painted
things
onto
have
the
to be,
bottom.
P127. Do you have a like a screenshot or a write up of what your solution to this is? I'm curious. I'm not as well versed on number theory, so.
Oh, okay. So he's referring to hints. The hints referring to is that
Thanks,
A and B
P127.
are
Appreciate it.
the numerator and denominator cases, not the actual A and B.
I lied. I don't.
Yeah, we see problems. I saw that too, and it's like, well, no, that's not true.
Okay, I gotta run to go teach teach another student. But this was a cool question.
We found a hard one to end on anyway.
Yeah, it was a good one to end on. I think P127 said he was, P127 said he was going to write something up, so we'll check it later and see how it's going. I do have to go run. I have to go teach another
Head out
student.
now.
I do.
Where are you rating your group off to?
What's up?
Where are you rating your group off to?
Oh, we'll see off to. Well, we'll see. Let's end the stream. Okay. Thank you everyone for coming out. Zach Education Office Hours today. I had a fun time working with all you guys. We had some fun questions, some number theory, some good stuff involving
A lot of number theory, to be honest.
A lot of number theory today, actually. We had some
and grid, which is I knew was gonna be a monster.
Yeah, we had some fun ones, including
a little bit of geometry,
some
but
geometry, a little bit of real stuff, whatever. This was
trigonometry, and then a little bit of extra
anyways,
number theory.
All right, nice. That's the last stream of the week. Our next stream will be Monday. That's gonna be at 3 p.m. Pacific.
It doesn't have to be the last stream of the week. You know that rule.
We could get a guest. I don't think I can get a guest today. I'm too busy.
On Thursdays, surprise stream.
Surprise!
It doesn't always have to be.
I would tell. The students they love their streaks. Nice. So, but yeah. So come on by the stream on Monday at 3 o'clock Pacific. That's the next time we're gonna be streaming free homework call for you guys. If you want to ever check out, there's a calendar showing when all your favorite streamers are streaming.
I'm gonna head on out. Enjoy.
All right, good. Thanks, Seth.
Bye.
So this is the schedule. So it looks like Zach is streaming tomorrow.
Series, and then Saturday we're back with math with EDTRPie. So.
Yes, Zach's doing math on Saturday morning. That's fun. Okay, cool. And it looks like Talos is still doing intro calc on Sundays. So, yeah, come on by to these things. They're super fun. If you just go to calendar.actual.education, that's where you can find it. And then be sure to follow all of our awesome math streamer friends. If you're on Twitch, very easy to go follow them there. I should get their YouTube channels as well. Anyways, okay, cool. Let's see who we want to go raid. Appreciate you guys coming by. I gotta go teach another student. It's actually a cool thing they're learning. They're learning how to approximate logarithms using other logarithms. Maybe I'll do it on the stream here next time or something. Nice. Appreciate the follow there. Deterministic polynomial. Wow, that's a cool one. Let's see who else is. Which one of our friends is streaming today? So Globus is doing biohybrids. Ooh, I love this. Oh, this is a new. Yes, yeah. It's like yeah. Those types of logs. Yeah, Jeff, we'll do those. Those are actually really fun. Let's go raid Ask a Scientist Gaming. They're a cool channel. They have scientists that come on and play video games, and then they also answer questions. Looks like they just started their stream. Dr. Chantel Buggs, Sociology of Dating, Racism, and Media in the Oregon Trail. This is a pretty interesting stream. Whatever, go say hi to them. They're cool. I like them. I like the model. It's similar to our AMA on Fridays, where we have guests and we have questions from you guys. But yeah, okay, awesome. Have a wonderful rest of your week. Enjoy the weekend, and we will see you guys on Monday. Peace out. Don't die of food poisoning on the Oregon Trail.